All right, folks, I'm going to do a walkthrough of homework one and going through an R script, essentially what we just did in class, but I'll talk through things so you have this as a reference. So let me share my screen, go to RStudio. Let me hide this menu bar here. Just a second. I'm going to try to do this in one take, so please bear with me. All right, so in R, to create a new script, we'll click this new file button up here, new R script. That'll pop up in our editor. It's called Untitled1, so if we want to save this, save it just like a regular file. Think of it as a text file or a Word file or whatever. So I go to Save As, and here I'm in my desktop. You probably want a folder designated for this class. So to save it in, I'll call this R Homework 1 Walkthrough. Okay, so my script is saved. The first thing I'd like to do is load whatever libraries I need to work in this session. As a reminder, we're going to load, they're called libraries or they're called packages. And when we need to load them in every time we use them. So in this case, I'm going to load in a library called Tidyverse, which we've used in class. Tidyverse contains a bunch of different packages and lots of functionality. If you get an error at this step, it means that you have not installed the package called Tidyverse, and you need to do the install.packages and put the package name in quotes. And you need to run this once on your machine. I think everybody's done that, but if not, go ahead and do that. It'll ask you a question. Do you want to compile from something or other? You can hit no to that if it asks you that. But you only need to do this once on each computer. You don't have to do it every time. So I've already done it on this computer, so I'll delete that. Okay, we've loaded our library tidyverse. Now it's available to us to use. I'm going to use well, first I'm going to look at the data sets that are present in R. What can I use for this assignment? And what I'm going to do, just like we did in class, I'm going to use the orchard sprays data set, which is the potency of orchard sprays. Now, I don't know anything about this data set, so I need to look at the help file, which we can do in a second, to figure out what it is I'm looking at. To load it in, if we just type orchard sprays, and run that line of code, and you can see I'm running code by hitting Control Enter on the line. You can also highlight and run. You can also click the Run button. It prints the data in the console, but I want this data to be an actual object in my environment. So to do that, I'm going to call it lowercase o, give it the assignment operator, which the shortcut is Alt, or I believe Command on a Mac, dash, and write out orchard sprays, run that line of code. So now this data set, orchard sprays, has been assigned to an object that I called O. You can name it whatever you want. You could name it sprays, you could name it OS, whatever you want. And it shows up over here in my environment. If I click this, I should be able to view it like a spreadsheet. Could also view it using the function view. Notice the capital V. That will bring up another tab here. I can look at it. So what we've got here is we've got some column that says decrease and some numbers. Row position, column position. I believe this is it's written over here. This is an experiment. So you've got like rows and columns of orchard trees, and then they all get sprayed. And then the treatment type is represented by a letter. Cool. So when I look at this, there's really one type of the graphs that we have talked about that would be appropriate for this, which is the box plot. And the reason why is because treatment over here is a categorical variable. It has discrete categories, A, B, C, D. And then we also have decrease, which is a numerical continuous variable. And the proper plot for that combination is a box plot, because I'm going to have categories on the x-axis, and then I'm going to show the values, the spread of the values in the y. So that's what I'm going to go for, is a box plot. To do a box plot, so a hashtag, well, Well, first of all, I'll annotate everything. So assign the orchard sprays data set to an object called O, view the object. So we're going to create a box plot. So the first thing to write is ggplot. This will set up the basic information. We first tell it what data set we're going to use. The data equals O, under lowercase o. You don't want O in quotes here. That won't work. We're just referencing this O that we just created. We're telling it the data we're going to use is stored in an object called O. Then we need to give it an aesthetic because it needs an X and a Y axis. So it's going to map the X values onto the, or it's going to map something onto the X axis and map something onto the Y axis. So the X axis, because we're doing a box plot, it's going to be categories. That's going to be the treatment. And so I write here the name of the column in the data set. And you might want to look back at it and look at the name of the column. It's treatment. Another way to look at the names of the columns, just as an FYI, look at names of data columns. This is in O specifically, is names. So we just type it names, lowercase o. It'll print out the names of the column. Now, this may be a little confusing because treatment here does not need to be in quotes, even though it shows up in quotes here. That's just mostly a ggplot convention. So it doesn't need to be in quotes. Then I need to tell it what the y-axis is, and that's going to be the decrease column. Okay, so if I run that, I'll get a plot, but it won't have anything on it. It's just the y and x axes, but you can see that the values are there. So it looked at the data and it arranged these axes based upon the values in the data set. Next, I'm going to add to this basic plot a box plot. And the way I do that is I type a plus here. And then a geom, what I'm going to do is geom box plot. I'm just going to leave it blank. We're just going to use all the default values. So that worked, and we can get a box plot here, and you can look back at the slides to know what these are. So the thick line in the middle is the median. This is the interquartile. This is the 75th percentile or quartile, the 25th percentile or quartile, the interquartile range. The whiskers here, the lines are the 1.5 times the interquartile range. And then these circles are potential outliers in each category. So this actually gives us a lot of information, right? We can see that the treatments have been arranged in order of sort of increasing effect size, so that whatever the treatment is causing decreases in something that we'll have to figure out very strongly. And treatments A and B don't really seem to be doing much of anything. Treatment F has a lot of variation. So it's causing a decrease in these orchard trees, but not in a consistent way. And that's because the data are like some values in the F are all the way up over 100, some are below 25. So that's cool. And the things we want to change now is we want to customize our labels a little bit. So ylab, and then in quotes, because we're going to create a text string, stick it on the y-axis. I'm going to put decrease in volume in milliliters. And the way I knew that is because I looked at the help file. I'm going to do this up here. Look at orchard sprays help file. And then we do that with a question mark and then the name of dataset. That'll bring up a help option here. Now, depending on who wrote this, it may or may not have the information you're looking for, but this is a good starting point. So here's the description. An experiment was conducted to assess the potency of various constituents of orchard sprays in repelling honeybees using a Latin square design. We don't need to worry about that right now, but you could Google that and read about it. It's a common way to do experiments. So we're trying to repel honeybees, actually. And when you look at the details, individual cells of, if you don't care about this, you can skip this part of the video, but I'm gonna look at this a little bit. Individual cells of dry comb were filled with measured amounts of lime sulfur emulsion in sucrose solution. 7 different concentrations, ranging from this to that, were used. The responses of the different solutions were obtained by releasing 100 bees into the chamber and then measuring the decrease in the volume. Aha. Interesting. So we're actually measuring how much the bees are eating this sucrose is sugar solution. And they're putting in lime sulfur emulsion, I think, to deter the bees from drinking the sugars, which would be, in the trees. So the decrease in volume is that's right. It doesn't, I'm not seeing here what the volume is measured in. So this is, maybe this is standard knowledge, but I don't know what it means. Like 1 in 100 of what? I don't know. So we're just going to assume milliliters. If this was your homework assignment, you could say something like the unit of volume was not provided, and so I assumed it was milliliters. That would be a good thing to do. And then the treatments are just different concentrations. So we don't know exactly what they are, so that's why we're going to just call them letters. Anyway, back to our plot. So we're going to call that decrease in volume in milliliters, and that's right here. So we've changed that y-axis. I'm going to change the x-axis label as well because I'm going to make it a capital treatment. And if this were my plot, I would write concentration of sulfur. Concentration of sulfur, they spell it. Concentration of sulfur. Okay, cool. So again, we don't have units here because it doesn't tell us what the units are, but again, that's something you would just like explain to me in your data or in your homework. So just need to be mindful. You can see that I'm clicking over here with the parentheses. Every open parentheses needs a closed one. You can see they highlight where the closed one is. So if I'm missing one, that's not good. Because if you're missing one here, you should get a little X over here, and it'll tell you. But it's ours expecting a closed parentheses. It doesn't see one, so we need to add that there. All right, let's run that. Every time you change something in a plot, run it to make sure it works. Cool. So that's it. That's all you have to do for this assignment. Let's customize this a little bit just for fun. As I said in class, so yeah, if you want to end the video now, if this makes sense to you, I'll put the script on Canvas. That's great. I'm going to customize this plot a little bit and walk you through that. So let's do a couple things. First of all, let's turn all of the fill, which is the white in here, to, what was the color we used? Rosy brown, I think, in class, rosy brown. Now, if you want to know your color options, you could type colors, I think, or color or colors, open and close parentheses, run that line of code. It gives you a list of all of them. So you could try these different ones. Here you go, the rosy brown. Now, why did I do fill instead of color? Well, let's copy and paste this and see what color would do. Color refers to just the outside edge of the box plot. See that? And then fill is the inside. So you can actually customize it more than one way. So this is fill, and this is the other one's color. Cool. So then what we did in class is, what if I wanted each treatment colored differently, which means that what you want ggplot to do is look in the data set, like it's going to color things according to the letter in their treatment. And ggplot can do that, which is fantastic. But what we have to do here, I'm going to delete this because I'm going to compare these two. What we have to do here is a couple things. First of all, this is called, up here, this is called setting the fill. Down here, what we're going to do is mapping. Setting is manual. I want everything to be rosy brown. Mapping means I want the color, or the fill, I should say. I want the fill to depend on the value in the data set of the treatment, A, B, C, D, etc. So fill is going to be not a single color. We're going to actually tell it the name of the column we want it to color it by, which is called treatment. So every treatment is going to get its own fill color, which is fantastic. However, there's a problem with this because whenever you map something instead of setting it, you have to put it into the aesthetic function, which is abbreviated by AES. So I need to put an AE, because if I just run this, it thinks I'm telling it that treatment is the name of a color, and I want to assign that color to all the fill in my plot, but that's not true. So R is confused, ggplot is confused. So I need to wrap this, I need to put this into a function called AES, and I need to add an extra parentheses here to make sure these are both closed in the right manner. So now I'm mapping the aesthetic of fill to the different treatment types. It's going to automatically assign each a different color. So we'll plot that. There we go. This is the default color scheme in ggplot. I believe it's somewhat colorblind friendly, but there are there's lots of color palettes. There are all sorts of customizable things in R. And we just have the basic one here. Now there's a lot more we could do with this. We could change the theme to kind of alter the appearance there. We could add a title, it's just called GG title. I'll call it like sulfur effects on B sucrose consumption. Okay, so that'll stick a title at the top of the plot. That's good. There are endless possibilities, and we're gonna do a second data visualization, like a whole class period on some of these customized options. We can change things like where the legend goes. So where the treatment, do we want to put this legend on the bottom? Do we want to change the word treatment? Do we want to change the colors of the plot or the legend? Do we want to remove the legend? There are endless possibilities. And most of these you will do by Googling, by trial and error, by searching, looking for examples. That book I referenced, R for Data Science, has like tons of worked examples in it. So it's kind of like a recipe book. You can use that. Like I really want to try to do this thing or that thing. For the purposes of our assignment, this is all you need. Caption, this would need a caption. So I'm going to write the caption in here, but you would need to write this like in the Word document. So I'd say something like a box plot showing the effect of different sulfur concentrations. And I'm gonna make this a little bigger. I'm just writing this here to give you an example, like an example of a caption. Sulfur with a U. I'm gonna say treatments. Applied to trees to deter honey bees. The y-axis shows the decrease in, they spell sulfur. Huh. Applies to the decrease in sucrose consumption by bees. Data, actually data is plural. Data are from an unknown experiment. I'm putting that because in the help file, it doesn't really tell us when this happened, where this happened, who did the study. You might have some more information that you should put, like data were collected in New Hampshire in 2005. That would make the caption complete. Captions need a date and a location typically, and an explanation. So this would be a good caption. This is all you need. For your interpretation, I would interpret this just as like we talked through. I'd say something like treatment, which is sulfur concentration, is obviously clearly having an effect on bee consumption of sucrose. Treatments A and B seem to be ineffectual; they're not really working. Whereas treatments I would say E through H are all highly effective, and treatment F has the most variable effect because of this large spread in the data. That's it. That's how you do the assignment. So hopefully this is helpful. Reach out with questions, troubleshoot, work together. A lot of R in the beginning is trial and error. So good luck. Reach out when you need help.